66 million years ago, a colossal asteroid, estimated to be about 6 miles wide, slammed into Earth near the Yucatan Peninsula. This catastrophic event, known as the Chicxulub impact, marked the end of the Cretaceous period and the reign of the dinosaurs. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs detonating simultaneously. This event triggered a sequence of catastrophic events that would forever alter the course of life on Earth. Imagine a scene of unimaginable destruction, with shockwaves rippling across the planet, igniting wildfires that raged for thousands of miles. The impact ejected trillions of tons of molten rock and superheated dust into the atmosphere, engulfing the globe in a thick, choking cloud. The immediate aftermath of the impact was a living hell for any creature unfortunate enough to survive the initial blast. The skies darkened, casting the world into a state of perpetual twilight. Temperatures plummeted as the sun's rays were blocked by the dense cloud of debris. The air itself became toxic, filled with noxious gases and vaporized rock. This event was not just a regional disaster, it was a global apocalypse. The impact triggered tsunamis that surged across continents, drowning entire coastlines. Earthquakes of unprecedented magnitude shook the planet to its core, reshaping its very geology. The dinosaurs, after reigning supreme for over 180 million years, were now facing their ultimate test. The immediate effects of the impact were catastrophic for life on Earth. The intense heat from the blast, estimated to be thousands of degrees Celsius, instantly incinerated any living thing within a radius of hundreds of miles. Shock waves radiated outwards at supersonic speeds, flattening forests and triggering massive earthquakes and volcanic eruptions. Those dinosaurs fortunate enough to be far from the impact site were not spared for long. The real killer was the global environmental catastrophe that followed. The massive amount of debris ejected into the atmosphere blocked out the sun, causing a sudden and dramatic drop in global temperatures. This impact winter lasted for months, if not years, plunging the planet into a state of perpetual darkness and freezing temperatures. Without sunlight, plants withered and died, disrupting the food chain upon which all life depended. Herbivorous dinosaurs, starved of their food source, perished in massive numbers. Carnivorous dinosaurs, their prey vanishing, soon followed suit. The reign of the dinosaurs, which had endured for over 180 million years, was coming to a swift and brutal end. The impact also triggered a cascade of other environmental disasters. The intense heat from the blast ignited massive wildfires that raged across continents, releasing even more soot and ash into the atmosphere. The impact vaporized massive amounts of rock, releasing toxic gases that poisoned the air and water. Acid rain fell from the sky, further polluting the environment and killing off any remaining plant life. The Chicxulub impact was an extinction-level event, unlike anything Earth had experienced before. It was a stark reminder of the immense power of nature and the fragility of life in the face of cosmic forces. The dinosaurs, once the undisputed rulers of the planet, were now just another casualty in the long history of life on Earth. The quest to understand the timeline of dinosaur extinction after the Chicxulub impact has captivated scientists for decades. Fortunately, the Earth has kept a detailed record of this catastrophic event, preserved in layers of rock and sediment. By studying these geological formations, we can piece together a clearer picture of what happened in the aftermath of the impact. One of the most compelling pieces of evidence comes from the KT boundary layer, a thin band of sediment found in geological formations around the world. This layer, enriched with iridium, a rare element found primarily in asteroids, marks the precise moment of the Chicxulub impact. The presence of shocked quartz, another indicator of intense pressure and heat, further confirms the impact hypothesis. By analyzing the fossil record above and below the KT boundary layer, paleontologists can track the fate of different species. Below the boundary, fossils of dinosaurs and other Cretaceous-era creatures are abundant. Above the boundary, these fossils disappear, replaced by the remains of mammals and other animals that would eventually dominate the Cenozoic era. The fossil record paints a picture of a rapid and catastrophic extinction event. While some dinosaur fossils have been found in rocks slightly above the KT boundary, suggesting that some populations may have clung to survival for a short period, The vast majority of dinosaur species vanished abruptly. This suggests that the impact triggered a cascade of environmental disasters that rendered the planet uninhabitable for most dinosaur species within a geologically short time frame. The discovery of the Chicxulub crater in the Gulf of Mexico provided further confirmation of the impact theory and helped refine the timeline of events. Scientists estimate that the impact occurred approximately 66 million years ago, marking a clear boundary between the age of dinosaurs and the rise of mammals. The Chicxulub impact didn't just end the reign of the dinosaurs, it transformed the Earth into a radically different planet. The immediate aftermath of the impact was a period of intense geological and atmospheric upheaval. Earthquakes, volcanic eruptions, and tsunamis reshaped the planet's surface, while the impact's ejected debris blanketed the atmosphere, plunging the world into darkness. As the dust settled, a new set of challenges emerged. The impact had released massive amounts of greenhouse gases into the atmosphere, triggering a period of rapid global warming. This warming, combined with the widespread destruction of forests, led to a dramatic increase in atmospheric carbon dioxide levels, further exacerbating the greenhouse effect. The oceans, too, were in turmoil. The impact's shockwaves triggered massive underwater landslides and tsunamis, disrupting marine ecosystems and altering ocean currents. The acid rain that fell from the sky acidified the surface waters, killing off plankton and other marine organisms at the base of the food chain. In the wake of this global catastrophe, a new world began to emerge. The once lush and diverse ecosystems of the Cretaceous period were replaced by barren wastelands. The few surviving plant and animal species struggled to adapt to the harsh new conditions. The impact had created a blank slate for evolution. With the dinosaurs gone, new ecological niches opened up, providing opportunities for surviving species to diversify and evolve. Among the survivors were small, mammalian creatures that had managed to weather the storm. These adaptable animals would eventually inherit the Earth, giving rise to the diversity of mammals we see today. The Chicxulub impact was a turning point in Earth's history. It marked the end of an era and the beginning of a new one. The world that emerged from the ashes of the impact was a very different place, one where mammals, not dinosaurs, would rule the land.